Hello everybody. Welcome to another amazing session of the Encode Chainlink 2023 Bootcamp. Astrid, who was here with you last week, isn't here currently, so I'm going to be filling in for her. And today, for session number 4, we'll once again be joined by our amazing friend Matheus Pagani from Venture Miner. Matheus will be joining us in a second or two, and he'll be talking about Chainlink's VRF, or the verifiable random function. So yeah, welcome Matheus to the stage. If you got any questions, feel free to pop them in the chat, and Matheus will get to them whenever he gets a chance. Thank you very much. Welcome. Enjoy the session, and yeah, Matheus, take it away.
Hello, Nevin. Hello, everyone. Thanks for being here today. We are going to learn some cool things about the Chainlink, about the tools of VRF and then automation as well. Uh, I'd love to hear a little about you as well. You can tell me here in the chat. Uh, you can tell me if you participated on Friday. If you did, I'll try to come up with new jokes. Always bad jokes, of course, but I'm going to try to be creative. Did you deploy your first smart contract already? If not, let me know on your background. If you know Solidity, if you know blockchain, let's start with me. I'm Matheus Pagani. I'm a software developer for more than 10 years. I work in a company for building Web3 and AI solutions, and I know a little bit about Solidity. Otherwise, I wouldn't be able to make it worthy of your time, I guess. Or I can improvise
A
right
little
now.
bit, just a little bit.
Well, not too much. Don't get your expectations too high, okay? I know my deal of stuff. But let me see. I have here Vanessa. Oh, good. You love bad jokes, so I got you served. I'm the person that can get you served. Okay, James deploys smart contracts. Great. Uh, Nice to see you again. Nice to see you again, Kartik. Hey, yes, sorry if I misspell your name. So, welcome everyone. Let me share my screen here. I would love to share one material. Let me do the entire screen. Why not? Let's start with a beautiful infinite mirror. Yay, here it goes. But I'm going to move that tab away. Okay, I still see you here on the right. First of all, let me share this link with you here in the chat. This is the README for the material actually for today's lesson, where you can find the expanded content, the explanations that I'm going to give today. They are all here, so you can read later on. You can experiment with it. You can open issues. If you want to ask me questions about this lesson, you could open an issue here and ask about something that is not working on your machine, that you didn't fully understand, that we would like to add, or some typo that you would like to fix. You can do it here. It is a great way for us to communicate because all the students can also see your questions and can collaborate, can answer all of this. Okay, and you can also reach me on Discord, on Twitter. Feel free to keep this going after today's lesson. Okay, I have one material for Chainlink VRF and automation because linked content, they all use the Oracle networks from Chainlink and the server function. So we are going to speak about those two this week. I don't know if you subscribed for the automations session on Wednesday. If you didn't, there is still time to do that. Okay. Only works on my machine. That's the greatest thing. That's a good because then you can ship your machine for production and problem solves, right, Rodrigo? So this is the material. If you would like to ask questions, there is a question pane here. You can use Livestorm questions to organize and upvote questions of other people. But if you post your question here in the chat, that's not a problem. Nevin will probably be able to spot that before than I do, and feel free to stop me if the question piles up. Okay. I will start with a short explanation about the idea of the VRF. And then we are going to head to the documentation, to the official documentation of Chainlink. Okay, I like to teach it that way, not only because the documentations are much well written than things that I would write, much more organized, but also because going to the documentation is something that I can never stress enough. If you are a developer, if you can remember things on top of your head and all of that, that is great. But if you are a new developer or building your knowledge around this subject or any other subject, remembering where things are in the documentation sometimes is much better than remembering the things out of your memory, because the documentation can update. There can be new versions of things, new best practices. The things can break from a version to the other. Okay, so if you don't remember how to do something, I don't remember how to center a div. Honestly, I don't remember. Ask me to do now. Center a div or I kill you. I'm going to die. But I know where to look for the documentation. Stack Overflow or ask ChatGPT. So this is what makes the ball keep rolling, if you know where to look for information. So we are going to learn from the documentation of Chainlink. This is just a side material for you to work, for you to read and for you to remember the information we spoke about. And also, I'm going to teach you hands-on. I have Remix open here with a simple token contract. If you attended Friday, you should have this contract in your Remix, in your workspace. If not, if you already know how to do a token contract, this is not going to be anything new for you, okay? I would like to teach you hands-on. I'm not going to use any slides or any prepare material, because I could be outdated, I could be wrong. So I cannot lie when showing things. I can lie when telling. I'm not going to lie, okay? Don't worry. But I could lie when telling things. Showing, it's impossible to lie, because I'm going to show things in blockchain. I'm going to show things happening and explain what is happening under the hood, okay? Matthias, this is a great conversation started. It's like, cut the short talk. Let's go direct to the point, right, Matthias? So, sorry if I misspell your name. Why we need randomness? Why we need randomness, something that is deterministic? Okay, so let's start. Before we even go for the documentation of VRF, VRF is a solution. Let's understand the problem first. I know as engineers, we love solutions. We don't like the problems. We build solutions and we love the solutions we build, right? But before we understand the solution, the solution would stand without a problem to attach. It would be without purpose. So let's understand the problem, right? Why would we need randomness from an external source if we prize something as if we prize something called determinism of blockchain? If we would like to make a drip function here, function drip. The syntax is not very important, okay, people? Don't worry if you don't know how to write this kind of function such. That is going to be a function anyone can call, and is going to be payable. Okay. And I want this to require that MSG value equals to a drip amount. Let's put 100 way, or 1 multiplied by ethers. Here, ETH. Forgot that syntax. See, let me demonstrate that going to the documentation, forgetting something. So I go to Solidity docs and constants, and we are going to find Solidity docs constants, and we're going to find it here into the units and globally available variables, and then it's ether into the singular, okay? So I don't remember how to do that on top of my head. Now I know. So this is going to be a drip function that requires that the value is 1 ether here. And now I'm going to do a function that I'm going to do a comment here. To do a function that if the coin lands heads, I'm going to drip 1 token. To do if the coin lands tails, I'm going to keep the money. This is a game, a randomness game, where someone is going to pay 1 ether and it's going to trust, it's going to call this function believing that it has 50% chance of losing the money or 50% chance of receiving 1 token of reward. This could be like a Joker token, something that you have odds of losing a lot of money when calling this, but also if you get the money, it's safe. You got the drip function. Okay, the contract keeps the money. This would set a good starting point for you, Matthias, or everyone else here following today's lesson. I'm going to pay for that function at least 1 ETH, actually exactly 1 ether. And if the coin that I'm going to throw when calling that smart contract lands on head, I'm going to drip 1 token. If it lands on tail, the contract keeps the money without giving the token. Make sense? Matthias is typing. Let's see if we have questions. No questions. If you have questions about this syntax, I can briefly explain what is happening as well, okay? Okay, Matthias. So where randomness would be used? Okay, this is more like a business side of it. I wouldn't use randomness in D5, for example. This is something that is already provided by the actors. In a gamey thing, in a security thing, you could find all the uses for randomness. Okay. Okay, Timothy, just like 1 minute here. If you want to expand more, ask the questions here, because this is a function that is able to receive money. If I don't use this payable keyword here, this function is not going to be able to receive it. When I call it, I cannot pass value. Okay, so this is the base thing that is needed for that drip function to receive money. And also I'm making a requirement that the value is 1 ether. Okay, I did that just to use that constant to make the conversion easier, but I could do like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and blah, 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 blah. Okay. Why I did 1 multiplied by 1? To waste computational resources. Okay, I could do 1 ether as well. No problem. Okay. And remember that is good to look at documentation. I forgot how to do 1 ethers. I can go here in 1 minute and find the documentation. It's easy to recover. I don't get blocked by it. Okay. You are following the settings here. This is a randomness that needs to be called. So I should have another function here. Throw coin that is internal, and it is pure or view and returns a boolean. And I'm going to make this boolean equal math.random modulus by 2. And here the history begins. Okay. Matthias, why it's a big no? You could, after you get that token, you could sell it for 1.1 ETH and profit instantly, right? So this is something you could bet on. You could gamble. Okay, throw a coin. Thanks a lot. Having it internal, it's because I'm going to call it from drip. Okay. Internal and public. Public means that I'm going to be able to call it from outside. Internal, it's just from inside the same smart contract. There is a great foundations bootcamp to learn on these things, and you can do the Solidity bootcamp as well if you really are into Solidity and bad jokes. I can get you covered. Okay. The thing is, math.random is not possible to do inside the blockchain. Let's stress that. I could do that in the EVM, some crazy way, but I could come up with a random number in the EVM somehow. The problem is, if I somehow come up with a random number into the EVM, that needs to be included in a block. Right? I didn't start VRF. VRF is a solution, okay, people? Let's stress on that. VRF is a solution. Let's spend a few more minutes understanding the problem, okay? So I can couple the solution over the problem. This is something that is not possible to do in the blockchain. But imagine if I could. I found a crazy way to do randomness inside the EVM, okay? If I do this, if I have a random outcome here in this show coin to use in that token, when I submit that transaction to the blockchain, when that blockchain accepts a block with that transaction, let's say this is this transaction, okay? I pick a random transaction here into the block explorer, and this transaction calls a state change. So it calls the state change here. Let me pick a smart contract call, a random smart contract call, yeah, like this. Lot of weird things. Send message. Okay. So this transaction here, this random transaction I encountered in the blockchain, calls it a state change. So there was a state before and then a state after happened. There was a number 0 that changed for 1, or a Boolean that changed. Okay. So this kind of functionality, math random, even if was implemented, would cause a state change here in the blockchain, depending on that outcome. Using a randomness source on who's computing that transaction, right? On who is including that in a block. Are you following? The next time someone is going to validate this, next time someone would do all the block confirmation, the second block confirmation, the third block confirmation, they would need to process that transaction again, right? Let's say we got heads. The second time we are confirming, we get heads again. Okay, we are lucky. So confirming. The third time we try, we get heads again. Okay, we are lucky. And the fourth time someone is confirming this, it got tails. And then tails again. And then heads and tails. How to determine who is right and who is wrong for that consensus? How is it possible to determine who is right or who is wrong? The first one to do that is correct. Well, but who is first? It is a decentralized network. There is no single source of truth for who is first and who is last. You see the problem? So even if we could implement in the EVM something to get this math random working, this drip function would be incompatible with the deterministic behavior of a blockchain. Okay? Let me know if that's not clear for you. This is the problem that VRF solves. We are not going to spend time solving a problem that we don't understand. So this is the problem. Since blockchain is deterministic, we cannot have a math random to inside the blockchain to determine this outcome. Okay. An easy solution would be to agree on the result earlier. But if you agree on the result earlier, why to do randomness? Randomness is exactly something you cannot control, right? I'm going to throw a coin. Okay. It landed tails. Now bet. Bet on head or tails. But it landed tails. It doesn't make sense to use randomness if you can determine the outcome. So, incompatible. Randomness, blockchain, incompatible. Okay? So, good to have you all today. Hope you enjoyed. See you for the next one. Of course not. This is the problem we have, but we also have solutions. Okay? Rodrigo mentioned from block rundown. Okay, it is possible to pick the block previous rundown. Because this is how it's done. I should need to convert that for a uint. That should okay. Type of bool. We are using an older version. Okay. Equal to 0. Bool. How silly of me. Turn. Because I didn't put the name at return. Okay. Yeah, I forgot the variable name. Usually I do like this. This is what got me confused. But that works as well. Okay, so this is the settings for Trollcoin. Rodrigo, it is possible to use the block difficulty here, but that's another thing, okay, that is rundown. This is a whole another talk. For you to use a rundown, you would need to implement a cliff period here. It's not for the content today. If you want to know more about this, Solidity Bootcamp, again, it's a great source for you to expand. So this is the problem of randomness. The solution from VRF is to have the Chainlink oracles structure, the Chainlink oracle network, to work for you with verifiable random functions that you can ask this network to generate from you off-chain. Let me ask you a very philosophical question. The off-chain world is deterministic. Well, depends on your point of view. If you know all the variables, like if you control every single variable in the world, temperature, pressure, the speed of each atom or molecule or whatever, it could be deterministic. But as we know of, it is not. So we have a lot of non-deterministic process to generating randomness, at least from things that we cannot easily control. But we don't have like a godlike super lab to know all those variables, right? I guess we don't. So if we use this information from outside the blockchain on-chain, we can guarantee a good source of entropy, a good source of randomness. The problem is, if I'm doing that for determining a drip, something that is worth money, it's too easy to cheat. I think I get the message that I want. I want this coin throw to land heads, so I drip one token and I input that on chain. And if the price is big enough, I could even bribe the block producers to put the information that I want the time I want. So yes, picking the information from off-chain solves the randomness problem, but it creates another. If we can agree to always do that, we have lots of devs here, right? So whenever you fix a bug, you create another, okay? So we can keep our jobs. We are always going to have jobs to do, because you solve a problem, you create another, and then infinite money, right? Infinite demand for the industry. Just kidding. Getting the information from the off-chain solves the problem, but creates new bugs or surprise features, like I said, Rodrigo. This is something that VRF solves using the Chainlink Oracle, because the Oracle network is incentivized for putting this information trustable in time. Whenever you want that information pushed to the network, you can pay using a link token to incentivize this behavior. And if the network misbehaves or publish a function that the publishes a value that cannot be verifiable, then the network can be punished. It can be slashed for much more of the damage that the value they would extract from that. Okay. I see some questions about the block difficulty that would be for the pre-rundown. That works, but it's another way to do. Okay, another architecture, another system, and it was quite recently implemented. Chainlink VRF was there much before this, much before the merger, and has its place. If you can combine those two, it's even better. Okay. So I'm not teaching anything outdated. In the contrary, I'm teaching something very actual, something very recent that you can, that is actually very recent, and that you can compose for your randomness sources whenever you need. Okay. Got the idea? Using the Oracle network to provide this information from off-chain in a way that is trustable, in a way that you can at least guarantee that the financials incentives are aligned. Okay, you're not going to have one single person to rig. You would need to rig all the network, and that would be too costly for a single lottery throw or something like this. Okay, this is a very interesting concept to remember, that security in decentralized networks is all about incentives. Okay, because you could have people misbehaving all the time. Blockchain is something that is fault tolerant. You could have faults all the time. If you incentive people to not fault, not to be corrupt, not to lie, then you have the probable outcome that people are converging, entering consensus. Okay, and this is one of the biggest changes for blockchain compared with all the decentralized network options, right? So the decentralized Oracle network of Chainlink has the same principle. It cannot guarantee that you are going to have a correct answer from the consensus of the network, but it can give great incentives for people to behave correctly. That's the end game here. You can say, oh, okay, but the Oracle network could lie, could give a wrong answer, could give a compromised number. That is correct, but they don't have incentives to do that. They have too much to lose. Here is where we use the decentralized Oracle network of Chainlink to add the security on the randomness we want. If the price is too big, if the jackpot is too big, like $1 billion, okay, then you could have a possible incentive for exploiting this. This happens for everything blockchain related. Okay, 100% game theory, yes. So to request randomness from this network, we are going to find two possible ways to fund. We cannot request it for free. Okay, I have this explanation on how the VRF works here. The first step is to give, let me enlarge this picture, is to give a link to the smart contract, to put a link to be used for that network. I cannot get this information for free, this randomized information for free, and I hope you understand why. If I get this information from free, randomness from free, I'm not going to have that game theory, that financial factor to incentivize the network. Okay, then I could have an exploitable answer. The more we pay for the network, the more secure you can feel about it. And yes, I know this defeats some of the purpose of the gaming part of asking a randomness for a game, for something that doesn't have big money value. But also, there are other sources of randomness you can use for things that are not so valuable, you see. I teach about those as well in the bootcamp. So this is for things that are more worthy, that you would pay link tokens to secure with this randomness. Okay, and then we start from here for giving the links for the smart contract use. This would be the first step. You can do this in two ways: by creating a subscription that you fund the subscription with link tokens, and then you can get this information, this random information, from many other smart contracts, okay? Like an ongoing basis. If you have a system with lots of different smart contracts consuming randomness, different randomness calls, and all of that, you can use this subscription model. Or the one that is more easy, more direct to the point, is the direct fund. Every time you want to request a randomness from a smart contract, you pay with link for that call, for that single request. Okay. This could be easier to calculate the price of that conversion. Okay, because then you can do the estimate transaction by transaction. You can estimate the link cost at that moment, the gas costs, and know exactly what you need to pay for funding that request. Okay, so it's easier because of this. But also, if you are going to do lots of sequential calls, lots of different contracts calling for the same randomness, you would have much more overhead in calculating those gas for all of this. This is useful for infrequent one-off requests like we are going to do in today's lesson. Okay, let me zoom in a little more. Okay, see if that's readable now. For today, we are going to use this direct funding. Okay, so we start from this step of changing link, of transferring link for that smart contract that we're going to ask the randomness from. Okay, and yes, it involves cross contract calls. Instead of explaining this whole thing theoretically in your head, I invite you to click with me to go for this get random number documentation page. Okay, that no, not here. Here, get random number from the direct funding method documentation page, and click on things with me. Poke around, see them breaking. That's the idea. Let me paste here in the chat. So we are going to explain this. Don't worry, I'm going to get this covered, but I'm going to get this covered in a much more visual way, so you can try it out on your machine. You can follow those steps and see it happening. Okay, so then you see, so this is what is happening. Okay, now let us look under the hood, and it's easier that way, at least for me, and for some people agree that learning technical things with technical experimentation can be more enlightening, can be easier to understand than just reading all the theory, and this is piling up on your head. Okay, so let's follow this. The links are here into the article, so we are going to do this Chainlink experimentation. There is a bit of explanation here. We're going to use the method of direct funding. Okay, so to set it up, we are going to do those steps. If you want to follow those steps with me, you can go for this tutorial here. Okay, this tutorial link. Follow those steps with me until the end of today's lesson. We are going to have consumed randomness from the VRF. Okay, you learn more by breaking stuff. Yes, poking around and seeing them break, because when you read something, let's read this. let's read this explanation. When you call the VRF, the smart contract sends a request from randomness to the VRF coordination along with some payment in link tokens as a seed value, and the seed value can be an arbitrary input, blah, 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 and then the coordinator assigns the request to the registered Chainlink node, and then they answer with some cryptography, blah, 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 to ensure the randomness. I'm sure you could understand this. If I read it out for you and do analogies and all of that, you could understand it, yes. But from understanding and being able to apply, there is some work on digesting the information, fighting yourself, what I need to do next. And this work can be reduced, this effort can be reduced if I just show you how to do it here on Remix following this tutorial. Okay. Does it mean that you shouldn't read the documentation? A big no. But it's easier to read the documentation after you experiment. Okay. So this is the dynamics we are going to do today. Get your hands on it, experiment, and then you can see the documentation what is happening. Before we begin, we are going to need 3 requirements. The Remix IDE. If you develop already, you should be familiar with this. If you attended last Friday, you should be familiar with this. We're going to use MetaMask as well, like we did Friday for signing transactions. And we need some balance in Sequoia testnet ETH, okay, for signing those transactions. To do this, you can, what it is, you can ask ETH from the faucets of Chainlink. And while you are there, let me send this link for you. While you are there, you can also ask some link tokens that we are going to need in the next step. Okay. Yes, we need to pay. We just explained that. We are not going to use this randomness for free. The good part is that we are going to pay with fake money that we are going to get for free. I wouldn't require payments, mainnet payments from you today. So I'm going to connect with my MetaMask. Here, I'm going to unlock my wallet. And I'm going to ask for this faucet to give me some money. Free money, please. So I'm going to mark that I'm a human. Oh, sorry, people, I cannot proceed with this lesson. I'm not a human, actually. I cannot choose those pictures. Imagine if you are following a tutorial with an artificial intelligence. This could happen in the near future. And then there is a captcha, and then the artificial intelligence can proceed. So you follow those steps on your side, initiating a faucet transaction for receiving link tokens that we are going to need for today's lesson as well. You should have some testnet ETH as well, like 0.01, something should get you covered. If not, I can sell you one Sequoia ETH for $1 each. Just kidding. Could get gold ETH much cheaper than that. You're gonna be rich. I know some people that have big bags of testnet tokens, like they use it to run validator nodes and such. So this is the first task for today. Very, very easy. Getting free money. If all the lessons started with that, getting free money, that would be cool. Let me know if you have problems here. I can see the transaction hash completed. Transferred link for my address. If I see here my address, let me do this. if I see my address here, I'm going to see those tokens. So I have almost 5 Sefolia ETH, and I have 37.59 link tokens that are going to be enough for today's lesson. Okay, make sure that you have some good amount of link tokens as well. After we do this, we are going to interact with this sample contract. Instead of setting up directly, we can click on opening on Remix. Here, you can find this into the documentation. Just sent you the link a while ago. To open a Remix tab, Remix workspace with everything you need. I'm going to close some tabs here just to have the content clean for you. I've claimed my link tokens here. Now I'm going to open this in Remix, and I'm going to have this contract to start interacting with the sample contract called VRF version 2 direct funding consumer. Okay. You should do that on your side as well. This is a very handy way to start because all of the conditions for implementing VRF are taken care for me here in that sample. The things that we would need to do, that would be inheriting from the Chainlink contracts, the Chainlink library, that would be VRF version 2 wrapper consumer base. Getting this set up at the constructor here, line 62, with the proper addresses, and doing all this setup of the owner and all of that, instead of doing that manually step by step, this VRF2 version 2 direct funding consumer contract is already taking care of all of this for you. So if you want to implement a contract to, I'm not going to say the whole name again, a contract to implement the VRF version 2, you can follow the same design, import the same libraries, inherit from those libraries, and copy the functions that you are going to need for your project. Okay? Those would be the 2 steps. Let me see if I have questions. No questions here. Don't know if I missed anything in the chat. But okay, this is a contract that can ask for a random number in Chainlink. If we compile this smart contract for generating the bytecode and deploy to the testnet, instead of deploying to a virtual machine, I'm going to deploy to a testnet. We are going to be able to call those functions. The function of request random words, the function of fulfill random words, all of those functions that are present here in that smart contract. Okay, I'm going to explain the most important ones here. Let me fold here, being easier to navigate. Fold here and here. Okay. So set up the contract, VRF version 2, blah, blah, blah. Compiled, I'm going to deploy to a testnet network to Sefolia in this situation. Those addresses here that are hard-coded in that contract only work in Sefolia. Okay, so be sure to connect to that. And I'm going to deploy that smart contract. It's going to cost me a little. This is why we need Sefolia ETH. But when it's included in the blockchain, we are going to have the base sample working. Okay, so we are in step 1 here. We compiled. Step 2, we deployed on Remix with injected Web3 environment. And then I'm going to have the contract address deployed here to the blockchain. Okay, you can view that on Etherscan as well. So it's deployed. The smart contract is here. We can start interacting with it. Feel free to interrupt me if you have any troubles. So far, it's just deploying that contract. Okay. Just remember this VRF version 2 direct funding consumer Sol is a sample contract that already takes care of the heavy lifting of importing the right contract, setting up at the constructor. Okay, and we are going to learn how to use VRF using it. I didn't change anything in the contract, Peter. Just click on Open Remix, and you are going to have the same code. Okay. Now that we deployed, we can start poking around and breaking that contract, right? I'm not going to break it. But for example, the contract is assembled in a way that I am the owner. My address is set up as the owner here. I have a function called last request ID that is going to show the ID of my last request here, 0, because I didn't request anything. And I have some functions to request randomness from the network. Now that we have those buttons to press, this drawing is going to be much easier to understand. Because we are here in step 1, just willing to start step 2. If we want to jump directly for step 2 and calling the function to consume the randomness, we can, but that's not going to work. Remember, we need to pay for the network in link tokens. So if we request random words here, that transaction is going to fail. Okay, the gas estimation errored with the message. Transaction will likely fail. Okay. This is something caused by the absence, the lack of link tokens. I need to send link for that contract. This tutorial suggests that if we fund this contract with at least two link tokens, this would be enough. So we already did the testnet, the 2 for the price of 1, the testnet link. We are going to send the link for that contract. 2 tokens should be sufficient. So I don't have a button to send link for it. I'm going to do that through MetaMask by copying the address of my smart contract that I've just deployed. And I'm going to send link tokens from my MetaMask contract. 2 link tokens as suggested. How to do that? How to make MetaMask be able to transact link tokens? You just need to add the link. Let me open this article here. You just need to add link token to your MetaMask. My screen is frozen. What? Oh, okay. Are you seeing the fund your contract? Okay. Might be network issues. So this is the article. Let me send here in the chat if you are experiencing problems. You can add the address for the token to your MetaMask. Okay. In Sefolha here, we are going to have this address. You can even click on add to a wallet here. This button, right? Add to wallet. Then this is going to add a link to your MetaMask wallet. So you can track, and then you send it for the smart contract. Now we can properly execute step 2. That is interacting with that consuming contract by calling the function that is going to require randomness. And this logic of requiring randomness here, request random words, it's all up to you how you do this. Here they are tracking this implementation with the request ID. Later on, this request ID is going to be very important for this function, fulfill random words. Okay, and this contract is going to keep track on the randomness responses by here on the get request status. For example, what is the status of the request 0? We don't have request 0. Okay, that's not going to answer anything. But if you ask for a number that is a valid request, for example, last request here, this would work properly. Okay. Let me just see. My remixing should be frozen. Don't know. Let me see. Yeah, that might be a problem. A problem for the future, not for now. So to make this call happen, to initialize this call here, I'm going to call the request random words call here. Transaction is pending. What transaction is pending? Let me see. Do we have a pending transaction? No. Let me do this. Let me disconnect here. And then I'm going to connect again. Attach this address. Seems to be working now. I'm going to call this request random words. Okay, now it popped up my MetaMask. This is going to initialize the transaction. This part here, then step 2 to 4, initialize the transaction from randomness. This transaction is not going to be fulfilled at once. No. Unless this goes supremely fast, that I hope not, when we finish this transaction here, the last request ID is going to answer with the ID of that transaction. And if I ask the status of that transaction, perfect, this is what I wanted. We have an information here about fulfill that is false. We request the randomness by calling request random words. This is the ID of the randomness request. Could have thousands in parallel, that's possible. And this request is not fulfilled yet. This is going to be asynchronous. This is going to take a while. It is not possible to have decentralization, security, and instant resolution at the same time. We are going to defer the resolution for a few seconds in the future. Okay? Try and do that on your side. You're going to have this same result. You get the status of the last request you did, and you should see fulfilled equal to false. This is going to take a while, but the VRF service is going to use the decentralized network, decentralized Oracle network of Chainlink to compute this workload, this work function. And after some blocks have been passed, you can answer back to the fulfill randomness. You don't have a promise. You don't await. You have a function fulfill randomness that after a while, this is going to be called to do something. And this is another logic that you can alter. In your smart contract, when you're doing your game, your NFT mint, whatever that you need randomness for, you are going to have a fulfill random word that is going to react for the parameters received. It's going to receive some random words here, an array of numbers that you can store. If we wait long enough, when I get the status here, look, now I have the random words. 2 random words generated for me, 2 numbers that are provable to be random, inputted by some people, some off-chain people inside your smart contract in a trustable way. And why you should trust those random people to be providing this random number because of the Chainlink network, because of the decentralized network they built for incentivizing the good behavior. The game theory here working in favor of us to incentivize this good behavior. Okay. So this is what is being explained in that last leg here. The network is calling back your contract, you fulfill random words contract, and this is going to mint an NFT. This is going to determine the winner of that lottery. This is going to determine the winner of that game. Okay. So this is not, Rodrigo, this is not deterministic for the randomness, but it's deterministic for the blockchain. The random is calculated at the time in the future. So you send the transaction now. 6 blocks from now, 8 blocks from now, 10 blocks from now, that randomness is going to be calculated and inputted back into the blockchain. So at the time you are sending that, at the time you are sending that call, it's not deterministic, you see. And this is it. Sounds very complex. If you look at this graph, a lot of steps of a coordinator emitting an event to a network and blah, blah, blah. But for the user, that is very abstracted. You just fund the contract with link, you request the randomness, and then you have a function for this randomness being fulfilled for you. Okay, and there is an article here about the good practices. Let's expand on this. This is probably going to answer some of those questions as well. Here, good practices, no security considerations. That yes, when you are going to send this request of randomness, the confirmation time, it will vary between the blockchains, between the amount of blocks that you ask. But the output is going to be calculated from the randomness at that time. So for example, when that is going to call your fulfill randomness, if you re-request the randomness, you are opening something to be exploited. The person re-requesting should be able to withhold or not the VRF fulfillment in its own favor. So whenever you are doing this, consider that this is going to be fulfilled by another person that could or could not behave properly, could or could not be corrupt. And because that is going to be done in the future, you should only, for example, request the randomness once. If you request it twice, then you are going to have opportunity for the same randomness. If you request it twice, you are going to have an opportunity for being exploited. Another thing about a security consideration, the fulfill randomness must not revert, because this is not going to be retried. The network is not going to try to call this again with all the parameters. Okay, so the safest way is to put that in your contract to be used later on if it's a transaction prone to being reverted, because you see this is going to be called from another person in the future. Yes, Matthias, that's a great comment there. So the determinism is granted because the function, this is something, this is also in that graph here, the function that is being executed is the same for everyone. The VRF coordinator passed that event at a specific time, that block confirmation parameters. So it's not possible to choose what kind of randomness you're going to do. It is that randomness. So if you provide a wrong answer, it's not an answer that was known at the time it was requested. But in the future, if you pass a wrong answer, it's easy to be verified that this is not the randomness that should be proposed in the future. Okay? Fulfill randoms is not like a callback. It is behaving like a callback, but you cannot call this as a callback because actually for the blockchain, this step here is just another person calling the blockchain. Blockchain doesn't know that this is a callback, blah, 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 in that architecture. For the blockchain, this is just another EOA interacting with that function. You see? This is not like a in-chain, on-chain callback or blah, blah, blah. This is just another random person, another EOA interacting with this. It's going to be safe because it is safeguarded by random people calling this function, all of that. But for blockchain, this is not a callback. This is just like a normal function that behaves like any other in the blockchain. Okay?
Cool.
So,
I think that brings us to the full hour. Yeah. So thank you very much, Matheus, for once again for the amazing session, and thanks everybody else for coming. And I hope you learned as much as I did. And I see the chat is very active, which is very nice to see, and so it was a good indicator of a nice session. Yeah, like Matheus said, the next session will also be held by him in 2 days' time on Wednesday, and he'll be talking about automation. Until then, see ya and have a nice day. Bye.
thank you, people. Bye-bye.